In cybersecurity, adversaries try to hide in the noise. So you're looking for something that's like 0.003% of all the data. In order to find every one of those, which is important, you need to scan the entire graph. There's just no other way.
Welcome to GraphGeeks in Discussion. I'm your host, Amy Hodler, and today we're diving into how graphs are reshaping cybersecurity. I'm joined by two fantastic guests, David Haglin, CTO and co-founder of Rocketgraph, and David Hughes, a graph and AI expert and principal solution architect at Enterprise Knowledge. I've invited the Davids to explain a unique approach, graph-wide scanning, that promises to eliminate blind spots. So let's go ahead and dive in and get started. So David Haglin, I wanted to start with you. You are a research scientist at Pacific Northwest National Labs, working on graphs and a project. Can you explain how you got started with this project and what kind of problem you were trying to solve?
So that project was going on when my first day of work at PNNL. I had spent an academic career doing graph theory, graph algorithmic theory, and went to PNNL as a new job, and this project was already underway, funded by the DoD. And the objective was build graph software that we can use in our mission, the DoD mission. So that's how it all started, and it ran for 6 years. For most of that time, for some of that time, I was a research scientist. Actually, for the last couple of years, I had taken over as project director of the entire project. But in the intervening time, I spent 1 year on site at the DoD, so I could see really how they're trying to use graph and what capabilities they really need. So
it's a nice way to get started, and I understand that's part of how Rocketgraph eventually came to be as well. David Hughes, switching to you in a little bit of your background and working on security related projects, because I know you work on a lot of variety, but how do you see graphs playing a role in the cybersecurity framework and people trying to accomplish things there?
Yeah, great question. First, I want to just really say how much I admire the opportunity that you had, David Haglin, because being embedded like that at PNNL and in the DoD, that is an approach that everyone is taking now. You look at Palantir, and you look now at recently announced consulting services coming out of OpenAI. They're all doing this new role called FDE, or forwardly deployed engineer. And it sounds like effectively you were maybe the OG of that concept. Anyway, so in the realm of cybersecurity, there is the traditional relational approach of trying to find known patterns in data. And that is sometimes successful, but the biggest lift or benefit comes from when you can see the connections between events, temporal chains of events, and then the other actors that are involved as corollary concepts to potentially a pattern that would indicate some kind of cybercrime, whether you're interested in AML for money laundering, human trafficking, or maybe even smuggling. The challenge, though, and maybe this will lead into another question, is it still puts a significant cognitive load on an investigator to know a priori what is the pattern you're looking for. And while it can be powerful, and over time that becomes a skill and an expertise, it is also somewhat narrowing, because that means that investigators are looking for known patterns. And we know that in a counterintuitive way, investigators are also the criminals. They know the investigative patterns, and they are exploring and investigating new patterns. So it's a bit of an arms race. And I think the traditional approaches of looking for known patterns is useful, but it's not comprehensive.
So to actually follow up on that, so how would an analyst who was looking for patterns or looking for something malicious at scale, how are they able to differentiate between something that's legitimate behavior and something that's not?
Yeah. Really, today's state of the art is the amount of time an expert analyst spends in looking at the data, looking at known patterns, and then trying to intuit what is novel, what are anomalies in what they know as being background noise versus what they know as patterns of some kind of cybercrime activity. And the newer tooling that we're starting to see coming up is, how do I embed semantics into a graph? How do I think about embedding heuristics into a graph? And then I think even newer is, how do I explore the entirety of a graph and understand or look for anomalies in patterns that I don't know about, but that still may represent a crime or something that I should dig into a little bit more and see if there's a connection. This is a connected data set after all.
Yeah. So I'm not being a cybersecurity expert. I'm wondering if maybe David Haglin, you could walk us through an example that I've heard the term lateral movement attack and how it's so hard to see. And I know what the word lateral means. So I'm making these assumptions, but I've also heard they're very hard with traditional tools to actually see them. But can you walk us through what that is and why graphs help with that?
So I tend to think about cybersecurity applications or solutions as graph. I have a hard time seeing a difference between those two. So I'm going to answer your question with a graph pattern. Okay. So at a high level, lateral movement is an adversary getting into the network, having basic level permissions or access. And what they do is they try to hijack and gain admin privilege and then go on to some other node in the enterprise that they've infiltrated. And unfortunately, they know that doing that over time, they can hide in the noise. So one particular kind of lateral movement pattern is waiting around for a privilege escalation event that they can be part of so that they can get their higher privilege, followed by hijacking a connection that already exists to some other node, and now they're in that other node in the network. So it's this sequence of events. Probably privilege escalation and hijacking is happening very quickly, but then they get to the next node in the graph, in the network, and they might wait there for several hours, maybe days, maybe even a month before that happens again. So this pattern is, let's think of it as a graph motif, right? It's this pattern of, I'm noticing a privilege escalation, and it could be one of 5 different types. And then there's this hijacking. And so that's one flavor of lateral movement. There's a lot of different flavors.
What you just described, David, is actually at a more granular level, ATO, or account takeover. So this is a meta pattern that I think intrusion, our adversaries have learned from account takeover patterns in the fintech world.
Yeah, wherever they're learning them from.
Yeah,
they are learning them, and now they have Gen AI systems at their disposal, so they can learn faster on how to do these things. Generally, this category is referred to as APT, or Advanced Persistent Threat. And they might have awareness of your network. They do reconnaissance while they're there, and they can sit there for 6 months, a year, before doing anything, before being noticed.
I think this idea of sitting and waiting is very, I think it is something a lot of people don't think about when you think about network security. You assume, you're going to detect something the moment it happens, and you're going to prevent people from being in your network. But the idea that they're already there, they sit and wait, and the reconnaissance idea is also I find kind of terrifying, because they may do one type of attack or behavior now, but are also planning things that may be done a year from now, or 6 months from now, or something like that. So the time dynamics of advanced persistent threat is, I find fascinating, and I would assume make it even harder to find the pattern, because you're not looking at a small slice of an obvious pattern. You have to see a longer view as well.
Yes. So if you think about how much cyber data you get in a day, And now imagine you need to look over 6 months worth of cyber data
Yeah.
to see if this advanced persistent threat is there and how it's progressed. That's way too much data. It just is way too much.
Especially if you throw on top of that, David, the fact that this is low-level signal. This isn't a active pattern like Amy was mentioning, where you're doing active surveillance for a motif, as you mentioned. It's actually how Amy and I first met. But you are actually doing passive surveillance for low signal in a lot of noise.
Yep.
So that kind of brings me to something else I did want to talk about. And I don't know if David Hughes, you want to kick us off here, because I think you were the first person to use the term that I encountered of graph-wide scanning. And so if you can explain what in general, you meant by that and why that's unique. And then maybe, David Haglin, you can talk a little bit about your view of that as well.
It is interesting that traditional connected data graph approaches rely on indexes. They're very important. They are the entry point into a graph domain or a universe of data. And if you have these initial anchor or entry points into your graph, and then you leverage the index-free adjacency or these direct pointers to other data, you can be fairly performant and assert that you are looking at the appropriate data. It's kind of like, not to get all mathematical, but it's kind of like the challenge, though, in ordinary differential equations, and you're trying to do simulation. You have to believe strongly in your assertions on your initial beliefs. And that's the problem with traditional graph approaches, or the challenge, not the problem. And that is, you have to have a strong belief in the starting points that you choose in your graph. And if your graph is small enough, there's some flexibility there. If you're talking large amounts of data that we would see in cybercrime, that we see in sensor data, or as our world is becoming more connected, so is our data, and that means that it's becoming just a massive amount of information. Being able to properly stick that or choose those starting points is getting very challenging, and you're leaving potentially a lot of information on the table in your analysis. But I'm curious, David Haglin, so would you agree with that concept for graph-wide scanning, and what do you think about that?
So one of the values or the benefits of using a graph is being able to blend data from multiple sources into the same resource that you can query.
Mm-hmm.
So as you think about adding more data, which is really helpful to getting the right kind of answers that you want, the data is growing that much faster. And a lot of people think, well, with the graph this size, the only thing we can possibly do is just take a random sample, and look for the. Oh my gosh, in cybersecurity, that is the worst thing, because you're leaving everything on the table outside of the scope of what you're looking at. Another possibility is that you start from a certain seed set or anchor, and again, maybe do a fairly complex search around that initial seed set, but you're looking at 1% of the graph. To see the big picture, you have to scan the entire graph. You have to look for the pattern everywhere. And the really valuable answers, especially in cybersecurity, are these. You have to do the whole graph. So I actually categorize the seed set or anchored thing. I call that graph lookup. And how you get to the anchor fast is important for performance, that kind of querying. If you need to scan the whole graph, the index to find a particular anchor doesn't help at all. So I think of that as actually a different kind of graph search problem. It's fundamentally different in how you optimize for it and how you get performance that's needed. And by the way, I don't like measuring queries per second for graph-wide scanning, because those two thoughts are completely distinct.
Yeah, they're orthogonal to each other. If you're trying to do transactional or small scale, and that's a relative term, small scale analytics, then your latency is important. Query, milliseconds for a query, that's a key indicator. But if you're trying to do comprehensiveness for intelligence, time's not as important or critical as long as it's still timely. But the performance at the millisecond level, that's not what you're trying to go for, because you're optimizing for the wrong thing. Here in this graph-wide concept that I think you and I are talking about, David, the optimization function is about completeness of result. And we're finding the same thing in agentic solutions now, is that as context windows in models are getting bigger, everyone thinks, well, I can just shove all this data in here and try and hope that it can sample the right portions. When in fact, what they're finding is that there's what's called a primacy bias. So what information is at the beginning of the context, and then a recency bias. And that's what's at the back, or what came in most recently. The content in the middle, the attention mechanisms in these models, it's losing attention there and not considering the completeness of this. And I think that that's where graph-wide scanning is addressing that issue by ensuring that the full context, the full amount of data is being attended to as part of a query.
In cybersecurity, adversaries try to hide in the noise. So you're looking for something that's like 0.003% of all the data. In order to find every one of those, which is important, you need to scan the entire graph. There's just no other way. So
graphs are uniquely suited to find long tail events, which in cybersecurity, and I would actually say innovation and true discovery of novelty, they're long tail. Otherwise, they wouldn't be novel. So so I feel like that is a natural fit for graphs. And I was listening to both of you talk a little bit about time and performance. And I think we've been trained to think about those elements in certain ways, but there are other ways to look at time. Time is so critical in cyber, but it's not that it's the millisecond time, it's the overtime that's important. And performance is important as well, but it's not queries per second. It's how do you, so thinking about these normal ways that we measure a solution, are maybe off depending on, if you need a large context window, that you don't want to lose, as opposed to, just processing really quickly for a stream or something like that. I know, David Haglin, you've talked a bit, and I've heard a little bit about the Rocketgraph performance. But I'm curious how you, thinking about this conversation, how you think about performance in this kind of a cybersecurity setting.
I just wonder if the paradigm at which, or the lens at which we're looking through when we say performance, maybe also needs to change a little. And instead of edges per second or millisecond, I would think that in the concept of our world is growing and the data is, and that we need to increase the context window of the information that we consider in our investigations, that maybe a better metric might be, what is the distribution of the concepts in this data in the completeness of the edges that have been considered in the response that or results that I'm receiving. So for example, if my graph is about actors and trafficking and, let's say, goods, that I want to see a distribution of the total data. 80 or 70% of it had to do with logistics goods, and 20% of it had to do with events based on the movement of those goods. And of the entirety of the graph, let's say some percentage in the 90s of that or higher, maybe it's the completeness of those concepts, all edges related to those concepts were considered in providing these results to you, the analyst. Maybe that's the more relevant metric here, is in a graph-wide search. It's asserting these are the concepts and the completeness that were considered. And that's why this result is more meaningful and likely more impactful.
So that's an interesting concept. I can tell you that in these graph-wide scanning searches, the number of edges that you traverse is directly linked to the amount of time it takes to run the query. Mm-hmm. And so the performance is really all about pruning the search space. Yeah. This is an exponentially sized search space. It's an incomplete problem. So how many edges did you transition over and during the search. So the other part of your thought there, David, is the different edge types. Some graph products don't, they're not strongly typed. Since our product was started in the origins that it was for the DoD with large graphs in mind and human time as the metric, we have strongly typed graph schemas. You cannot put an edge in without knowing its type.
David, that's a question I had for you. Is I'm in the camp of schema first. I see some value in schema free or whatever marketing terms are out there, but I see more value in schema first. And I have some thoughts about why, but I'm curious, why do you think what you've just described as a schema first approach, why is that so valuable?
Well, first of all, when you're dealing with pushing the limits of scale, one way to deal with that is if I have 3 different edge types and I restrict myself to looking at just one of those 3 edge types at this part of the search, then I have a smaller search space. Yes. So that's why we chose schema first initially. A better metric, I think, is how many traversed edges did you do on this problem with this software versus this software? I mean, if you wanted to do comparative analysis between a couple of different implementations, that's the metric we use, actually, is just the number of total traversed edges. Finding ways to prune that search space is the key.
Since we've kind of gotten into a little performance and some numbers, and everybody likes numbers, right? Is there anything, David Haglin, you can share with us?
Our one customer that has the largest machines can't tell us how big those machines are, but I had worked in that space as a forward deployed engineer 12 years ago, 13 years ago now, gosh. So I kind of know without actually really knowing. Not all the graphs they use have 1 billion edges. They don't all do that, but those are the ones that they find the most valuable answers from. Those are the ones that they're not able to deal with. So we at Rocketgraph think of 1 billion as we need to start there and go up. We need to prove that we can move in that space. We don't have to, that's not the only place we're usable by any stretch, but we need to be able to perform in those spaces. Yeah, so I have in the past run on 150 billion edges in a 12 terabyte system and ran a query that scanned everything multiple times. So 150 billion, I looked at 123 trillion edges during that query. So it was a graph-wide scan. And yes, it took 3 days, but it found only less than 4,000 answers. In a cybersecurity world, that's amazing.
Yeah, it's so important. So one, big numbers. Definitely got that. We're in the billions, or in trillions in the actual scan. But looking, I mean, that is the classic. I mean, I would say I feel like it's not just needle in the haystack. It's here's a haystack. You tell me if it's a needle or a thread or a pencil. You don't even know what it is you're looking for. You just know there's a haystack and there's something interesting in there. And so that's kind of interesting to kind of think about, that scale. Yeah, go ahead.
Amy, that's interesting that you use that analogy, because it's something else that I see as unique and novel in some of the approaches that David Haglin has been talking about. And that is, you said, is it a needle or is it a thread? And the thread is the one that intrigues me, because with a thread, you know that it's interesting, but you need to pull on that and explore it further. And I think one of the things that I've seen in approaches that use subsets of the data as a result, and I think, David, maybe you can keep me in the guardrails here, but you use something I think called a frame-based approach, where you can actually take a result set and then run queries on that result set and almost like chain them together. And to me, I see that as a unique capability of, to Amy's point, of pulling on the thread and teasing out, or maybe surfacing insights higher and higher and higher until they become visible. Is that accurate, David?
So it's fairly accurate. So let's go back to the strongly typed concept we talked about earlier. We have 3 different edge types. Each edge of type 1 has exactly the same set of properties with the exact same data types on each of those properties. And what I'm describing is essentially a pandas frame, conceptually what I've got here. And we call it an edge frame for that very reason. So can you pull on that? Let's talk about a little bit the Cypher query language and now the GQL standard query language. The answer of a query is a table. It's this weird non-closed, mathematically non-closed system where you ask a question and you get an answer in a different form. So you can't necessarily compose these things. So what do you do with a table? Well, we save that in memory, and we can give it a name, and we'll treat that as a node. Yet another node type in describing the query. So we can use that node table temporarily, think of it as a node, to start the query. And from there, chain back into the other parts of the graph. So yes, pulling on the thread using this technique is something we've baked into our product.
And I really like that approach because I never know what I'm really looking for when I'm starting to look for something. It's whether it's my email or it's an advanced query, it's this kind of investigative back and forth, and having that ability to kind of chain together thoughts and iterate, I think is really important because especially in cybersecurity, you are looking for the unknown, patterns.
Yes. Yeah, I like to describe this as playing 20 questions with your data. So if your data has 100 billion edges in it, how do you play 20 questions with this thing?
Yeah.
If it's going to take you 2 days to get the first answer, 20 questions is a long time, right? So we've all built into every step of our development of Rocketgraph, specifically for this kind of large scale, down selecting the right way to get to data that you can maybe visualize or maybe work with in some other tool. That's our value, and it's huge.
So David, speaking of baking things into a product, something I'm hearing more and more these days is we have baked in or bolted in AI into our platform or our product. And that's one approach. But the other thing that we're starting to see in startups are these companies, these young 2-3 person, maybe up to 10, 15 guys who aren't baking in or bolting on, but they're actually starting AI first. And I think that Rocketgraph has taken some of that approach as well. Can you tell us about some of the AI features that are first-class citizens in your platform?
Well, let me first of all remind you that we started as a company, we started 10 years ago, almost. And our first product was Graph Engine. AI wasn't a thing really for us. It was a graph engine driven by a Python scripting. We have an SDK for that. Our target user base was a data scientist. Jupyter Notebooks is probably what they would like to use. So we targeted that. And maybe we're a little late to coming around to realizing, we need to have a user interface, a real user interface, not Jupyter Notebooks. So we started that about the time OpenAI was hitting the tsunami, was causing it in Gen AI. So as we were developing this UI, we put Gen AI insertions into that user experience that we were designing in. So in that sense, from day one, we were schema first, right? Well, okay, so the reality is we had the ability to somebody write a Cypher query, and that lasted about 2 weeks, and then we figured out how to get the Gen AI system in there to do text to Cypher, so you can ask the question in a natural language, get the Cypher generated, you can review the Cypher, and eventually we got to the point where we're realizing that's the way people are going to want to use our tool, not Cypher. We don't have an audience that needs to know Cypher. And so in a lot of ways, the Gen AI insertion allowed this democratization of who can ask these 20 questions of the large data. So the large data capability was already there and has been for a while. This Gen AI user interface is where the new stuff happens. Now we have this insertion points where text to cipher can happen, and then you can run your cipher query and you can have a look at the answers and you can iterate through that. We're schema first. For a person who doesn't even know cipher, thinking about a graph schema might be a problem too. And so we've got graph schema generation capabilities inserted into our what we call mission control, our user experience. And then we also, I had no idea it was going to be this powerful. And we created just a general chat because I got tired of going to a different browser to ask OpenAI questions. So I just put it right in there. And then I realized I could just send in graph schemas along with my prompts. And so now we can do things like, I've got these two graphs, I want to stitch them together. What data do I need to add to this in order to get, so that kind of it's more planning for capability than actual data analysis.
I understand correctly, your primary user is the analyst, not the data analyst or security analyst, not your developer or your, somebody else.
For the operation of the mission control, the user experience, it is the analyst, right?
Nice.
The data analyst, not necessarily a data scientist, but it is a person who has got some domain expertise and they want to use this tool and we can be very productive. Now, a lot of cyber applications, having it be not human in the loop kind of deployment makes sense too. And we can do that. In fact, that's how we started with the Python SDK. So we can do embedded in workflows in an enterprise. We also support this hybrid idea where it's embedded and it's running and it's doing the scripted stuff that the enterprise needs, but then you can connect mission control to it and have a look around. But that's maybe not necessarily the primary use.
Is that it sounds like at the same time OpenAI was creating the flood of the initial waves of AI, that Rocketgraph was reinventing the interface to all of this graph-wide capability and I think large scale analytics or extreme scale analytics, that you saw an opportunity to put AI first into what is now Rocketgraph. Is that accurate?
We began with the idea that we were going to develop a UI. We had this contractor design a UI for us, and that never happened as it was because it didn't have any Gen AI in there. And as we were starting to add some meat to the bones of the design of this UI, we started adding Gen AI components as we were developing it. It never worked on its own without Gen AI. That was always part of it. Some of the injection points happened later, but especially that text to cipher, that thing that is probably one of the hardest parts for the non-data scientist to use, that was never required in our UI.
Nice. Well, I think in the interest of time, we probably have a couple more questions and then we'll wrap things up. So I have a question for both of you. One is, looking at the state of graph analytics in cybersecurity today, what is your take on that and where that's going? And I guess actually, David Hughes, if you want to start, with that, I'm kind of curious on both parts.
I think today's intelligence analysts and cybercrime analysts, they continue to be, I think, burdened with a high cognitive load in which to conduct their work. They have to think about the data engineering and the bringing into an investigation the right data. They then have to think about how to construct or compose queries. Have they got their data modeled the right way? And at the end of the day, I think that cognitive burden is resulting in missed intelligence. It is resulting in less efficient intelligence because there's only so many hours of the day that are then left for an analyst to conduct what they are experts at. And I think that the horizon holds a day where an analyst can come to their data and with very little, if any, effort, begin to investigate, to be an analyst, to use what their expertise, their experience, what they've learned over time looking at crime and the patterns that they are uniquely situated to reveal, that is the bulk of their day in front of a system. That's not today, but I think that that's where we need to get to. And I think with systems like Rocketgraph, that's probably where we are going to find ourselves in the near future.
I will provide a slightly different perspective. I think a lot of times cyber analysts get excited about understanding that they have all of the hashes to specific known malware implants. And as long as they don't see that, they're happy to feel good about or confident about their network. And it's all the adaptations that are going on, especially now that Gen AI can write code, they can adapt these known implants. And so it's not going to be enough to check out all the hashes of the implants. It's not going to be enough to say everything in the MITRE ATT&CK catalog we don't see. It's not going to be enough. We'd love to get to the point where in our Gen AI system, the analyst would come in the morning, get their cup of coffee. All of the relevant queries that need to be run had just finished when they arrived. And a Gen AI system read through all the reports of those queries and synthesized and summarized that and presented to the analyst saying, here are the things that are most important that just happened since yesterday.
David, I'm going to interrupt you for a second because I think that this is key. I verbatim heard that exact request from an analyst about 3-4 hours ago.
Okay.
I want to come in and I want to have a dashboard. Tell me, what do I need to know today based on what has happened since I last was in the system? And described it almost verbatim the way you did.
Wow. Okay. Well, Rocketgraph isn't there today. We're still growing out our user interface and our infrastructure. As you know, any product is doing that, right? But that's kind of where we're headed. That's our cyber goal.
And the last thing that you said, David, that maybe got my gears turning is it's not going to be enough to have, that's a great vision. I think it's also how do we put into our solution the ability to learn new patterns, because you said it right. AI is continuing to expand its capability and it is becoming the threat agent. There will be humans behind it, nudging it, guiding it, architecting it, directing it, maybe even giving it objective optimization functions of you're trying to achieve this. But at the end of the day, AI is actually becoming the threat operator, acting on instructions. And so our systems in the future are going to need to be just as agentic in their counterintelligence efforts.
Yeah, I started calling that vibe hacking because you're developing new implants using your vibe programming, right? And your goal is to hack. And in fact, I like to think about vibe red teaming and vibe blue teaming, right? Put these two agentic AI systems to test out the software or test out the networking infrastructure and have them record everything and get a report. Wouldn't that be amazing? That's kind of an interesting future vision of cyber.
So that leads to my final question, which is about what you're both excited about in this space, either that you are working on, reading about, or coding up right now. Like, what excites you both?
Well, I'll start. I'll say that users who don't even know that it's a graph and they're still very effective using our product. Mm-hmm. That is what I'm excited about. Of course, I'm a graph geek, literally. I have been since my PhD days with the word graph in my thesis title. And I love graph, but not everybody does. And I'm beginning to recognize that. So that's what I'm excited about.
I'm going to have to say, we all love it. They just don't like the name, or they just don't know it. They don't need to know it's a graph. Everybody loves connected data. Can't get away from that.
Connected data, that's the term du jour. So I would answer by saying, as much as I get super excited these days about the deeper integration of graph into agentic operations, specifically around memory, I think graph is the model for agentic memory. I would actually lean towards what David was saying, and that is that the future is upon us. We're not quite there yet, but we are, it's in vision of democratized access to immense amounts of data and intelligence to analysts. They no longer are having to be burdened with being data engineers and data scientists. The systems that are being developed today are going to allow them to focus on intelligence. And I think that's where we have this almost like periodic evolution in our punctuated evolution of intelligence.
I wholeheartedly agree. The more people that can solve complex problems without having to be computer scientists or, experts in data science itself, the better. So, and graphs are definitely the way to do that. So thank you both for joining us. Lovely conversation. I hope the one of just many. If people want to find out more about Rocketgraph, it is very simply rocketgraph.com. You can also find David Haglin and David Hughes on GraphGeeks as well. And reach out, ask questions, and I'm sure we'd all love to hear from you.
It was a pleasure. Thank you, Amy.
Oh, yes, it was very much a pleasure. Thank you.